to run you through some key investigative skills that you'll need for your AQA Science GCSEs. Just to begin then, something that you've probably all done before and you do it quite a lot, but calculating a mean. There are some really tricky bits that you just need to be aware of to make sure when you're going into your exam you're not going to fall foul of any silly mistakes. Firstly, what a mean is. It's working out the sum of all the values and then dividing it by the number of the values. That's the key bit. So if there are 5 sets of values, you divide it by 5. If there are only 2 sets of values, you divide it by 2. If we look at an example then, I've got some data here that I've just collected together, and I can see I've got some repeats for the time it took for my object to fall. What I'm wanting to do is work out those missing mean values. Again, some key ideas. Make sure you use a calculator. You are always allowed a calculator in your science exams, so bring one. Specifically, a scientific calculator. It becomes really important later on that you use one of those. What I'm going to check for first and foremost are anomalies. Now, if you're not too sure what anomalies are, well, they're anything that doesn't quite fit the pattern. So look at your data carefully and check what doesn't fit. So if I'm looking through here, I can quite easily spot I've got a piece of data here that just doesn't fit the pattern, and the same down here that doesn't fit. They're way out of the range of their other data sets in that column. I'm then going to think about calculating my mean. Now remember, if I'm using this row of data here, I'm not going to include my anomaly. So when I do my calculation, I'm only going to divide the values by 2 because I've only got 2 sets of data in that row. Whereas, if I move to my row below, because I've now got 3 sets of values, I'm going to divide it by 3 and come up with my answer there. On to our next thing, uncertainty. This is probably something that not many of you have looked at too much detail in lessons. An uncertainty looks at the range of the values, dividing that by 2. We get our range, as it says here, by taking the largest value, subtracting the smallest value, and dividing that by 2. Be careful that you don't put this in as one long equation in your calculator, because it will just divide your smallest value by 2 and take it off the largest. So as it says, put it in brackets if you're using your scientific calculator, or do it first and then divide by 2. If we look at some data, yet again, I've got my same set of data and I'm considering my same rules. I've got my calculator, it's my scientific one. Again, I'm going to check for the anomalies, make sure that there aren't any in there. Because I've got the same set of data, I've got the same 2 anomalies in the same pattern. What it doesn't mean, though, for this uncertainty, is I don't really have to worry about the number of values, but I do have to make sure that I'm not using this as my smallest value or this as my largest value. So again, if I go into my first row of data here, I'm doing my largest value, 0.82, minus my smaller value, 0.80. I divide that by 2 and I give my answer. Now the clear bit on here is my answer is given as a plus or minus value. Often you'll see that in the table already, but if it's not there, you need to make sure you add it. With my next row, again, there's no anomalies, so I just pick from the set of data whatever the highest value is, which is 1.05, take off 1.02, and it gives me a similar uncertainty to what I had before. So away from looking at data and doing calculations, what we can consider is our choice of equipment. Now, I've got 2 pieces of equipment on the board here, and I've got them as well with me. Both of these pieces of equipment are used to measure the volume of something. The issue is that they have different resolutions. The resolution is effectively the smallest value that you can measure with it. So both of these pieces of equipment will measure 250 millilitres of a solution. However, my measuring cylinder, I can see on it, I've got smaller values that I can measure to. And in fact, the smallest value I can measure on my measuring cylinder is to 1 millilitre. Compare that to my beaker, I can see even on this one here, the smallest value I can measure really accurately on here is probably 50 millilitres. So it makes the resolution of that 50 millilitres. The one in my picture here, I could probably measure to maybe 10 millilitres, so that has a smaller resolution. It's still not as good as my measuring cylinder. This is a more precise piece of equipment. It will get me better data when I'm measuring things. I've also got a top pan balance. My top pan balance has at the front of it the amount of grams that it will measure to. This lowest number here effectively is the smallest amount of grams that I could measure. The resolution for this would be 0.01 grams, because effectively that's what I can measure as its smallest value. Just to finish off then, we can talk about accuracy of our data, and we can quote accuracy. Accuracy links with our uncertainty, which we looked at calculating earlier. And we may need to indicate when we're talking about the uncertainty whether it is plus or minus that amount of the uncertainty there. It's considered to be accurate if it is judged to be close to the true value. So you would be given a true value in your exam and looking at comparing the data to that. So the data we've got here, you can see I've been given an expected value, a true value. So I'd be comparing which set of data is closer to that. And I can see data set 2 is much more accurate because it is much closer to that true value that you've been given. Last up, a couple of key words. Reproducibility, which looks at different equipment or techniques but getting the same results. And the final one that's quite tricky is repeatability. Repeatability is the same method and equipment to obtain the same results. So the key difference between reproducibility, different equipment, different techniques, different people, but same results. Repeatability, the same equipment, the same method to get the same results. You'll have to use these kinds of words, these kinds of terms all the time when you're describing any kind of investigation. And they're not just going to come up in your biology, they're going to come up in chemistry and physics as well. So think carefully about the types of words, think carefully about the skills that you're going to need to use, and the best of luck for your summer exams.